Introduce yourself, name, which university, and
Yeah,
if you
sure.
are outside US, which country, and within US, please state your
Yeah.
which
Is
state.
my screen visible?
Yes, visible.
Yeah, thank you. Hi everyone, this is Sohith. I'm from India, in specific South India, Chennai. I'm currently in my final year undergraduate engineering program, specializing in bioinformatics at SMATS University. And here I'm going to discuss a research paper that I've recently read, which is on brain tumor detection empowered with ensemble deep learning approaches from MRI scan images. It was published in 2025 in Scientific Reports Nature. So the major problem statement they have targeted in this paper is that there are like several AI techniques that have still issues with accuracy and dependability for brain tumor detection. So and also manual diagnostic approaches are often subjective, inconsistent, and also error prone. So the major research objectives of this study was to develop an effective method for brain tumor detection using deep learning and also to conduct a thorough analysis of tumor-free and also tumor-affected brain images, and also to evaluate the neural network performance by measuring per image precision and also per patient diagnostic accuracy. And they have utilized two models, Inception V3 and Exception models for brain tumor classification. So if you look at the methodology, they have taken the data set from Kaggle Brain MRI dataset. Originally, the data set was having around 2,870 images, and after augmentation, it became around 10,000. So what are the augmentation techniques they have used? Here you can see they have rotated the images like 0 to 25 degrees in 5-degree increments, and horizontal and vertical flipping, scaling up and down, Gaussian noise addition, cropping, smoothing, and all sorts of intensity adjustments. So from 2870, after augmentation, the set has become 10,000. And out of 10,000, there were like four classes, which had normal, glioma, meningioma, and pituitary. And per class, they were having 2,500 images. So out of the total 10,000 images, the data was split into 70% training set and 30% validation set. And now if you look at that architecture, they have utilized two models, which is Inception V3 and also Exception. And they have used a weighted averaging function. Here we can see the formula P CK omega P1 CK plus omega P2 CK. So here the weights are based on validation performance. And here this probability of CK represents the final predicted probability for class CK. And here, if you look at the model, for Inception V3, we have like 48 layers and it uses Inception modules and it uses 1x1, 3x3, 5x5 filter sizes with a computational efficiency with 1x1 filters. And for Exception model, there were like 71 layers with 36 layers for feature extraction with enhanced efficiency and performance. And if you look at the training parameters, we have like total epochs of 50 with a batch size of 64 with an activation and optimizer of Adam and softmax respectively. And they have used a dropout rate of zero point 0.2 to zero point 0.5 to prevent overfitting. And also they've used cross validation using K-fold to ensure consistent performance. And to avoid overfitting, they have treated the data before augmentation in order to prevent training or test set leakage. And also they have used a validation set for periodic performance assessment. So if you look at the accuracy, if you take alone only the Inception V3 model, the training accuracy was around 96.75 with a test set accuracy of 96.5. But with like an ensemble, like the combination of these two models, which is Exception, Inception, transfer learning model, the accuracy has improved with an accuracy gap of like 0.2%. And now, if you look at the key achievement here is basically the ensemble model here has consistently outperformed individual models across all tumor classes, as we can see, with like 98% accuracy, like anywhere about 95% overall. And here, if we compare with other models with recent work, here we can see with the Google Net, CNN, DenseNet, Feature Ensemble, Stacking Ensemble. So here we can see the accuracy is like just around 98.4, but with their proposed XITL model, the accuracy was around 98.5%, like 0.1% increment with a best overall performance. When I looked at their limitations, I could see that the data set size which they've taken was relatively small, even after augmentation, which is like around 10,000. And the diversity was not that great. And also, the real time validation, it requires extensive clinical testing. So, these are the few limitations which we can see. And the future research directions could be using explainable AI, which is very important. As Mridula discussed in her talk, she talked about a black box model, which is difficult for clinical interpretation. So we need explainable AI in order to develop grad cam, which is class average mapping, and also shapely additive explanation techniques in order to make the AI more explainable so that it aligns with clinical workflows and also regulatory standards. Yeah, that's it. Thank you.
Thank you, Sohit. Questions to Sohit?
Oh, well, that's a great presentation. So in terms of the time it takes with the combination, so how does it compare with the previous methods?
In terms of time,
Yeah, processing time.
if we look at the time, they haven't explicitly compared the time here. Yeah, they have just used the parameters accuracy, sensitivity, precision, specificity in this case, but not the time here. Yeah,
Okay, great,
yeah.
thank you.
All right, thank you, Sohit. The next presenter